Greetings and welcome to section 7.4. This is actually a pretty big chapter and a pretty big section, so we're going to actually split today's thing into 3 days. So 7.4 we're going to spend 3 days to cover. So today is really going to be about the basics. The stuff that we have to do isn't too hard, but big concept stuff today. A lot of stuff that's going to kind of flow over as to what we're going to do with the rest of the chapter. We're going to flirt with the idea of inverses. You guys know what inverses are. We've talked about them before. We've actually going to introduce, for the first time ever, we will be having logarithms. So the big connection with logarithm is realizing that a logarithm is an inverse of an exponent. Okay? There's a lot of stuff on the screen right now, a lot of stuff here, but really what I want to break down to is what is a logarithm, and the best definition that we can have of a logarithm is that it is an inverse of an exponential. And we've spent a lot of time with exponents lately, so logarithm is really what we're going to use to start solving exponential equations. It's what we're going to use to graph. It's going to really have a lot of cool things. Again, this is me talking, so I think it's cool because it's math. It's going to have a lot of cool things that happen in terms of domain and range restrictions and stuff like that. So a lot of cool stuff happened, but today, like I said, we're just going to get on the ground floor, and we're going to talk about the special relationships of what logarithms are, specifically how logarithms relate to exponents. So number one is, how do we read it and what is it saying? On the left-hand side right here, it says log base b of y equals x. That's the same thing as saying b raised to the x is y. And I will show you how this reciprocal relationship works in just a sec. I want to get us down with some vocabulary. Again, that's logarithm b. We abbreviate, or we just say log base b of y. That's how we speak to that piece. Two other things, and if you look at your calculator, we will be using the calculator a little bit today, so you might want to take that out. Find this button on your calculator. There's two of them. One of them is the common log button, and that's just the log button on your calculator. It just says log, and that means a log base 10. The other thing that you see on your calculator is a natural log, and that will look at ln, and the ln is the natural log, and that's a log base e. Remember we talked about e yesterday when we compounded our interest. So those are the two logs that are on your calcs. Most of the stuff we'll do with logs aren't calculator driven. So make sure you're okay. Common log is a log base 10. Natural log is a log base e. And generically, at the top, log base b of y equals x. So it's really kind of vocab and saying the word correctly. Next up, I want to kind of show you how it works. Big pictures here. I'm going to cover some stuff up, so don't worry about scribbling stuff down furiously. Just want to look on that left-hand side, the right-hand side, where it says b to the 0 equals 1. We've already discussed in class how anything to the 0 exponent is 1. The other thing that I'm going to talk about is anything to the 1 exponent is just that number. B to the 1 is just b. B represents any base here that we can have. And again, any base to the 0 exponent is going to be 1. Any base to the 1 exponent is going to be that base. We've already played around with that idea yesterday and the day before when we were making our parent functions on exponents. We used this idea right here. These were the two key values that we used in our graphs. So that's review. The left-hand side. These are identities. And this says log base b of 1 equals 0, and log base b of b equals 1. And really the big one that we're going to use is this one right here. Okay? This will also come into play a little bit. You're probably going right here, that's a lot of stuff. I'm overwhelmed right now. I don't know how this is going to fit together. Well, I want to take it with the easy part. Let's take it with the identities that we know, and that's going to go base 0 equals 1. So I'm going to take that. I'm just going to write base 0 equals 1. That's basically saying anything, any base to the 0 exponent is going to equal 1. And we've covered that in class. Anything with a 0 is 1. So let me show you how we're going to move things from exponential form into logarithmic form. We know mathematically, to undo problems mathematically, we do its inverse. For example, if I have an algebraic equation where I have x plus 4 equals 2, if I want to move my positive 4 over to the other side of the equation and solve for x, I do its inverse. What's the opposite? We say opposite, inverse, kind of same thing. Positive 4, I will subtract 4 from both sides of the equation, and that will give me x equals negative 2. Again, I'm doing the opposite. I'm undoing what needs to be done in order to solve that equation. And something that has held true ever since pre-algebra, if you do it to one side of the equation, you've got to do it to the other side of the equation. And then, as you moved into Algebra 1 from pre-algebra, we had something like this. And I said, okay, we've got 5x equals 30. We want to get x by itself. That says 5 times x, so we are going to divide both sides by 5. That's its inverse. Multiplication and division go hand in hand. They undo each other. They are inverses of each other. So there, I've undone it. I've divided both sides of the equation, and x equals 6. Mr. Wood, this is all very easy. I'm good at that. I get that. I do the same thing on both sides of the equation. I undo it. I solve for x. It's something I've been doing. If we could just do that every time, that'd be great. Well, I'm here to tell you that we can. Except for now, we're looking at exponents. And the relationship is that logs undo exponents, and exponents undo logs. They work hand in hand. Logs and exponents go like multiplication and division, go like addition and subtraction. So I'm looking at my generic function right now, and I have b to the 0 equals 1. All I want to do is change it from an exponential equation, which is what it is right now, into a logarithmic equation. In other words, I want to get rid of the base b. To get rid of a base b, that's here and here, I need to undo it by doing the log. So if it's a base, I want to get it to a log. If it's a log, I want to get to a base. So the inverse of a base is a log. So what I'm going to do is introduce a log base b, to both sides of that equation. When I introduce a log base b, there's my giant 1. Those guys cancel out, and it leaves me with 0 equals log base b of 1. So I've just gone from a base to a log. And notice that that's what we have right here. Log base b of b is 1. That's our identity. That's our inverse. That's our property that we're going to use the whole time. Okay? Again, if I want to get rid of a base, I'm going to introduce a log. If I want to get rid of a log, I'm going to introduce a base. There's big patterning here, and I'm going to look about 4 or 5 problems. I'm going to go slow, but what I'm really going to emphasize is this inverse relationship of undoing each other. Just like addition undoes subtraction, just like division undoes multiplication. Those are inverse properties. We're going to use inverses here with logs and exponents. First thing that we're going to do, all we're going to do is rewrite things from logarithmic form into exponential form. These things are saying the same thing, they just look differently. Hold on, pause, just a second.
Attention, Simran Rodriguez.
All right, sorry, there was an interruption there. All right, all we're doing here is changing from logarithmic form to exponential form. So log base 2 of 32 equals 5. That's the first one we're going to look at. Hopefully you got that copy down in your notes. Log base 2 of 32 equals 5. I want to change it into exponential form. That means I want to get rid of a log. To get rid of a log, I introduce a base. To get rid of a base, I introduce a log. I'll say it again. To get rid of a log, I introduce a base. To introduce a base, I introduce a log. So I have a log base 2 of 32 equal to 5. I want to get rid of the log, and I want to get into exponential form, so I will introduce a base. The base I'll introduce will match. So I want to introduce to log base 2 of 32 oops, didn't want to do that. I want to introduce a base, let me see if I can get that. A base of 2 to both sides of that equation. Again, base of 2 because log 2 to the log 2 is my identity. That's my giant 1. So the left-hand side of that equation, that's my cancel out, that's my dropout, that's my inverse property, that's like division and multiplication, that's like addition and subtraction. That takes care of my log. That's my identity. So that gives me with 32 on the left-hand side equals 2 to the 5th exponent. Remember, I introduced a base. I did not multiply both sides of this equation by 2. Again, I introduced a base of 2 to both sides of the equation. I did not multiply by 2. And the same thing works in reverse. I'm going to take that 32 equals 2 to the 5th. 32 equals 2 to the 5th. This is now in exponential form. That's what we just did. It's in exponential form. That's all we have to do for that problem. It's in exponential form. What I want to do is now change it from exponential form into logarithmic form. The way that I'll do that, if I have a base, I want to get rid of the base, I need to introduce a log. So the log I'll introduce to both sides is a log base 2. Is a log base 2. On the left-hand side, I would have a log base 2 of 32. On the right-hand side, there's my identity, there's my inverse, there's what's been undone, and I have 5. Log base 32 is 5. That's what I started with. Log base 32 of log base 2 of 32 is 5. 32 equals 2 to the 5th. These two things say the exact same thing. They're just in different forms. Again, let's look at the patterning. Part B. They give me 7 to the 0 equals 1. You guys know that anything to the 0 power is 1, so that's a true statement. But now I want to go from exponential form, 7 to the 0 equals 1, into logarithmic form. So I need a log. I need to get rid of an exponent. The way that I'll do that, I will introduce a log on both sides of the equation. I will introduce a log that matches that base. So it will be I'm going to write it over here because I need more room. 7 to the 0 equals 1. I will introduce a log base 7, to both sides of the equation because I want to get rid of the base. Bases and logs undo each other. There's my giant 1, or my identity. So 0 will equal log base 7 of 1. 0 equals log base 7 of 1. And again, these two things say the exact same thing. They're just in different forms. Some of you guys are starting to see the patterning here. These are very pattern-oriented. Just think of it in terms of inverses. Think of it undoing something. Think of introducing the same thing to both sides of an equation and keeping equality maintained. We have log base 13 of 13 equal to 1. You can see the identity is right there. Log base 13 of 13 is 1. That's a true statement. We've already used it several times. But again, I want to go from logarithmic form into exponential form. The way that I'm going to do it, I want to get rid of a log. So I'm going to introduce a base of 13, to both sides of the equation. There is my identity, my giant 1, and I'm left with 13 equals 13 to the 1. Remember, I introduced that base of 13. Last problem. I need to go from exponential form into logarithmic form. That is 1/2 to the -1 equals 2. That is in, like I said, exponential form. So we need to get a log introduced. We got to match our bases up. So I'm going to write that. That's 1/2 to the -1 equal to 2. I want to get rid of the base of 1/2. The way that I'll get rid of a base of 1/2 is to introduce a log with its matching base. Introduce a log with its matching base to both sides of the equation. There is my inverse. There is my undoing. And that gives me -1 equals log base 1/2 of 2. Once again, -1 equals log base 1/2 of 2. And that's really how it goes. Okay, pretty straightforward stuff. Just make sure you're comfortable with the movement. I'll tell you that today's secret word is the circle of life. The circle of life is today's secret word. Remind me to talk to you guys in class about how this relates to the Lion King, and I will show you how the circle of life works. So circle of life is today's secret word for lecture. Next up, checkpoint. Pause the video. You guys do those two real quick. Change the first one from log to exponential form. Change the second one from exponential form into logarithmic form. Pause the video, get them done on your green sheet, and unpause when you're ready to move on. Great. Hopefully you thought that was easy. It's supposed to be. Next problem. Evaluate these logarithms. Part A, log base 4 of 64. Part B, log of 1/4 equals 256. And part C, the natural log of 1. And I think there's a part D, log base 22 of 22. So I want to concentrate on log base 4 of 64. I will expect you to be able to simplify these by hand in class. Think about what we want to know. The name of the game, just like on the previous problems. Matching up bases, and using identities. So what we have to do here is match bases. And here's what I mean by that. Log base 4 of 64. I can't do anything with it right now. There's no identity there. But I can do this. I can rewrite 64. And the way that I'm going to choose to rewrite 64, some of you guys actually have this committed to memory, is 4 cubed. 64 is 4 cubed. So I'm going to rewrite this as log base 4 of 4 cubed. Notice that 64 is just being rewritten as 4 cubed. Well, hopefully you see exactly where we're going with this. Log base 4 of 4 cubed. There's my identity, and my answer is 3. So log base 4 of 64 is 3. That's it. That's as hard as it gets. Well, Mr. Wood, letter B, log 1/4 of 256, sure does look a lot harder than what you just did. Log base 1/4 of 256 is going to be a little bit harder, but it's just because it's a fraction. So here's what we need to do. once again, we still have to match our bases up. Log base 1/4 of 256, which really means we need to rewrite 256 as a base of 1/4. Because if I can get them to match up bases, then this problem's pretty easy. I'm going to give us some more room here. Let's see, rewrite 256 as a base of 1/4. I don't even know how to do that, Mr. Wood. Well, let's see. I do know that 256 is 4 to the 4th. So if I have log base 1/4 of 4 to the 4th, I'm good so far. Well, Ms. Wood, I don't know how you're good. You said that we have to make the bases match up. So I need the number 4 to actually be 1/4. Okay. Is there somehow I can write 4 in terms of 1/4? Some of you guys are thinking it. One-fourth to the negative 1 is 4. Again, 1/4 to the negative 1 is 4. Think of what we know about negative exponents. 1 to the negative 1, 4 to the negative 1. It means they're in the wrong spot. We have 4 to the 1 over 1 to the 1. Oh me, oh my, I'm shocked to see that 1/4 to the negative 1 is 4. Almost as if it's supposed to work out that way. That is the hard part. And that's as hard as it's going to get on today's assignment. So again, we're going to rewrite. That's log base 1/4. And now my 4 is actually 4. I'm sorry, I didn't write that right. My 4 is actually going to be written as 1/4 to the negative 1. And that, again, is raised to the 4th exponent. So I really have a funky way of writing 256. I've chosen to rewrite 256 as 1/4 to the negative 4. 1/4 to the negative 4. Let's look down right-hand side. You should realize that that's 1 to the negative 4 over 4 to the negative 4, which is 4 to the 4th over 1 to the 4th, which is 256. So that's how we've solved it. I've matched my bases up. I have log base 1/4 of 1/4 now to the negative 4. I now can use my identity. I can now use my identity, and the answer here is negative 4. Whew. Good news. C and D are easier. Letter C. That says ln of 1. I'm going to remind you right now that ln is the natural log. That's a log base e of 1. You need to simplify this. Log base e of 1. I think it's a little bit easier to see it this way. That's an identity. That's an identity that equals 0. How does it work that way? Anything to the 0 exponent is 1. Okay? Anything to the 0 exponent is 1. So this is an identity. Natural log of 1 simplifies to 0. Letter D is the easiest one on here. A kind of medium, B hard, C was an identity, D is the easiest one on here. Mr. Wood, that looks exactly like the identity that we've been talking about. In fact, that looks like the giant one we've been using. Uh-huh. So isn't the answer to that just 1? Uh-huh. It is. That's the easy one. Letter D, the easiest one on here. Letter B, the hardest. The other two are kind of mediums. But again, name of the game, match your bases up. Match your bases up and you can simplify. You guys, checkpoint and pause the video. I think there's only going to be 2. No, there's 3 checkpoints today. So I got another one pretty quick here. Evaluate the logarithm. Log base 3 of 81. And then log base 1/2 of 32. And pause the video, get those done. Checkpoint number 2. Unpause it when you're ready to roll. Okay, hopefully you're done. We're moving along. Just a couple more problems here. This is the part that you're going to use your calculator on, so I just want to make sure that you can do this. Very easy. Just finding the log of 8 in your calculator and the natural log of 0.3. So we need the log of 8 and the natural log of 0.3. Some of the stuff we're going to do, you do need to use your calculator on. So I need to find, this is mine. Yours is similar. It's pretty straightforward. I can't remember what we're supposed to do, though. Log of 8. For me, I just press log and then 8, enter. There you go. We're going to use these calculations later on. Just want to make sure that you can get the matching answer, though. And now I need the natural log of 0.3. For me, natural log of 0.3. Boom. Okay? And again, your answer should match what I got, and your answer should match what we have right there. Pretty straightforward stuff. So, not too concerned about that. The reason I wanted to show you that is because we're going to have to use our calculators in the next problem. So, here we go. The next problem. Tornadoes, wind speed in miles per hour near the center of a tornado can be modeled by S equals 93 log D plus 65, where D is the distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states. Estimate the wind speed near the tornado's center. So, wind speed, S stands for speed, shocking, S can be modeled by this equation. The problem told us to find S. It told me that D is the distance in miles, and they gave me D, the distance in miles. I'm thinking we probably should substitute in and solve using our calculator. What a great idea that is. S equals 93 log of the distance that we traveled is 220 miles plus 65. So this becomes a calculator crunch, which I'm going to do right now. The first thing we need to do actually is do the log. So log of 220 is what I need to do. Notice there's no base on this log. That's a reminder that we're talking about the common log. So I need to find the common log, which is the log of, I'll clear that out for you. That's the log of 220. It's that number. You can leave it in your calculator. You can write it on your paper if you want. I tend to just leave it in my calculator and do all the work. So there's the log of 220. The next thing it asks me to do is multiply it by 93. 93 times the log of D. So I will go, I'll just write that. In fact, in your calculator, if you just hit times after you've done the log, it'll take that log answer, so you don't have to put it in your calculator. That takes that log of that, and now I'm going to multiply it by, I forgot what number, 93. I'm going to multiply that by 93. Hit enter or execute at that point. That is 93 times the log of 220. 93 times the log of 220. The next thing we have to do is add 65. Next thing we have to do is add 65. Enter. And we get 282.845. We'll round that up to about 283. It's rounding to the nearest whole number. So I'm going to say speed is approximately, I forgot that number, 283. Speed is approximately 283, and this was miles per hour. That's my unit. So, bottom line in this case, don't be stuck in the middle of that tornado, because it's going about 283 miles per hour. All right, that's really as hard as it's going to get. Last checkpoint for you guys, this problem right here. Go ahead and pause the video. And actually, you don't even pause the video. We're going to be done, so you can pause it right here. As I'm talking, that's your third checkpoint for the day. Make sure you have all three of them done. This time we're talking about a hurricane and not tornadoes, but it's very similar. Should be using a calculator for it. Good luck. See you guys tomorrow.